We're going to learn how to use the calculator to solve the P5 function, how to make a function, and how to save time making an equation on the calculator. So starting with the logarithmic functions, right? So the function to find out the error in log is log of maximum value minus log of minimum value, and it equally applies on the ln function, the natural log, right? So for the first one, if I see that the maximum value is 2.9 plus 0.2, that will be 3.1, because the absolute error is plus minus, so that it actually sets up the range for the absolute maximum minimum values. So technically this is going to be log of 3.1 minus log of 2.7 divided by 2. Now, if you calculate this on the calculator, it's going to look something like this. Put on the fraction function, press the log function, right, with base 10, and this will be 3.1. Then use the edit key and simply put in the log function again. So that will be log with base 10 with a value of 2.7, and then simply divide this by 2. The answer that we're going to get is 0.0299. Now, since we know that absolute errors are rounded off to one significant figure, this will become 0.03. And since we want to find out the true value as well, so we are going to simply take the log of the value 2.9 separately. So log with base 10 of value 2.9 gives us the answer of 0.462. Okay, so we can write this down as a three significant number over here. So the actual representation, what it's going to look like, is going to be something in this way. So this is going to be 0.462 with the calculated value, then the error function or the absolute error, which is plus minus 0.03. Now the problem is that you can't do this for every digit that is available at this point. You can't calculate the error again and again, and you can't calculate, you will have to calculate the true values, but you can't do that for the error function again and again. So what we're going to do, we're going to make an error function of this system by seeing what is being repeated, what is continuously being repeated. So for the first four values, I can see that there is a common error of 0.2. So if I had to make the function in the calculator, so I'll use log of x plus 0.2 minus log of x minus 0.2, and then divide this by 2. What this will help me do is calculate the error function or the absolute error in the first four values with the very quick calculations. So let's see how to do that. So again, I'm going to clear the screen, write down the function in exact format as it is mentioned here. Now notice that I'm using 0.2 because that is what the error is. For the next stage, most definitely I will be using 2. Okay, so just watch the full video for the complete understanding. So pressing the fraction button, then using the log function with base 10, going inside the bracket. Now we use the alpha button over here. You can choose any button, you can choose any variable ranging from A, B, C, D, and the X, Y, and Z as well. So for now, I'm choosing A, and then simply writing plus 0.2. I could have written this down this way as well, it doesn't matter. Then I'll add the negative sign. Then again, log with base 10, go inside the bracket, use the alpha button, put in the same variable that you used for the first time, and then subtract 0.2. Now we've successfully made the function that we were expecting at this location, what we did at this point exactly. So just to be sure that we have made the function correctly from the long method, that is this one, we're going to put in the same values for the first calculation and see whether we get 0.03 or, to be exact, 0.299 or not. Now, in order for us to put in the values of our choice in place of A, we're going to press this button calc. That is beneath the alpha button, calc, observe clearly. So I press calc, and he asks me, the calculator asks me, what value of A am I supposed to put? So since we are calculating it for 2.9, and this is actually 2.9 plus 0.2, and this is 2.9 minus 0.2, So my actual value for x that is going to be acting for both of them is the true value that is represented over here. So I'll write down 2.9 and press equals to. Now he's going to confirm whether this is the final value. I can edit this again at this stage, but since this is what I want to put, I will press equals to, and you can see that he gives me all of the answer in a single step instead of me putting in 3.1 and 2.7 manually. Now let's see the benefit. I don't have to write down the full system again. I don't have to write down the full expression again like we have done at this point. We can just simply press the calc button once more, and it's going to ask me what is the next value. So I'm going to edit this for 4.9. When I put 4.9 at this point, he's going to add 0.2 and subtract 0.2 on its own from the function, right? So now we press equals to again. It tells me that the function or the error is plus minus 0.0177. I'm going to write down both answers, 0.0177. But since the error is up to one significant figure, I will write this down as 0.02. Similarly, moving on to the next one, I press calc again, and I will put now 6.9 in this value, press equals to twice, and it gives me the next error function, which is 0.012. So I'm going to simply write down 0.01 up to one significant figure. On the fourth stage, we have 9.8. So I'm going to put in 9.8 is equal to. Now, since this is going to be a very long number, right? So I'm going to press the ENG button to bring it out. So let's put Shift ENG to bring it out and see what the full value is. So this is 0.008864. So we can write down 0.009 up to one significant figure, right? Now, when we move on to the next idea, we notice that there is a change in the error function, right? We notice that now the errors are going to be plus minus 2. So what I'm going to do, I'm simply going to edit this formula again in place of 0.2, which I have found common for the rest of them, and just edit with 2. So I'm going to go back and use the arrows to go back to the formula and readjust this equation so that I can deal with this plus minus 2. Now you can see the function clip completely a bit more clearly, that over here we have a plus 2, and on the other side we have a minus 2, exactly like the log function or the maximum function, minimum function that we've already done. So now I press calc again, and I know for this time around I have a value of 16, so I'm going to put in 16, press equals to twice, and I get plus minus 0.05, right? Okay, then press calc again, I get 21. So putting in 21 gives me plus minus 0.04. Now, just to be sure whether we have done this correctly for this section as well, I'm going to try this with a long method again, which would have been for the first 16 plus minus 2 would have been log of 18, y, 16 plus 2, minus log of 14, 16 minus 2, because we have to find the maximum and the minimum, right? And then divide this by 2. Now, doing this manually, I can edit this equation again without going back. So this would be log of 18 is equal to log of 14. I press equals to, I get the same answer as I got before, right? So we have learned a new thing about the calculator. How can we use and develop a function just like over here, right? Let's try this for another example at this stage. Okay, so he tells me we want to find out the average, plus we have to mention the error function. We also have to mention the absolute error. So calculating the okay, going back, if we wanted to find out the calculated values, what we could have done simply is log with base 10, right? And just simply write down any letter, alpha B, okay? And then just keep replacing 2.9, 4.9, 6.9, 9.8 and the other values to calculate without editing this equation. So this is going to be simply put 2.9. This is 0.0462, which we've already done. So I've done this to recheck whether we get the same answer. Then press calc again. No need to edit the equation, just put in 4.9 and it will give you the answer of 0.690. Then press calc again. We have 6.9. Press equals to twice, 0.839. So 839 after rounding off. Then press calc again. We have 9.8. So we have 0.991. Then we have calc 16. This will be 1.20, right? Then press calc again. We have 21. We'll have 1.32. Okay, so we've just quickly solved out the whole table, and now we can move on to the graphical analysis, and we can use these coordinates to plot on the graph, okay, for P5. So let's move on to the next equation. This is a simple system. It wants the average of two values and also wants the uncertainty in those values. Now we know that the generic idea of uncertainty or the absolute error is the maximum value minus the minimum value and divide this by 2. Basically, they want to find out the range of error so that it can be written down as a plus minus thing, right? So your maximum value exists at this point. Your minimum value exists at this point. When you divide this range with 2, it finds out a value for the maximum number. Let's rewrite this again. So we have a maximum value and we have a minimum value. When they divide this by 2, the whole range, then it gives you a value for the maximum and it gives you the value for the minimum. So collectively, it's written as plus minus. So since this is the basic idea, we're going to move towards a simple calculation, and then we're going to make the formula on the calculator to take help from it so that we don't have to edit the system again and again. So simply, if we have the first answer is 0.19 plus 0.13, so divide this by 2. So again, use the fraction symbol, 0.19 plus 0.13. Use the edit button or the arrow button to come down and press the SD button to get the final answer. So this is 0.16. So this 0.16 plus minus to find the error. We're going to use this formula, maximum minus minimum divided by 2. So this is going to be simply an edit function, right? So this becomes 0.03. A plus minus of 0.03. Okay, you can counterintuitively, you can do the same thing for this one as well. You can use the fraction symbol, then place an alpha A minus alpha B. And be advised, you can use the other functions as well. C, we have alpha D, we have alpha E, we have alpha F, and you can also find X, you can also find Y, you can also find M. So there are multiple variables that you can use to do anything that you want. Right, and don't be scared to try other options as well. You can do square, you can raise it to any power that you want, for example under root alpha C as well, right? And no matter how many times you press the calc button, he will always ask you what you want for A, what you want for B, right? So after you've put on these values, he's going to solve this for you. Okay, so using the fraction button, again we go back and design the formula. So this is alpha A minus alpha B divided by 2. Since 2 is a constant part of the equation, we're going to use it as it is. I press the calc button. This is what I'm dealing as A, and this is what I'm putting as B. So 0.22 is equal to, then 0.28 is equal to. So now we convert the answer. So it gives you that answer again. Okay. So let's try this for 0.22 and 0.28. So alpha A minus alpha B divided by 2. Press the calc button. He's going to ask you about the value of A. So 0.22 is my answer. Then he asks you about the value of B. 0.28 is my value. And then I press equals to again. It gives me the answer of 0.03 again. So this is plus minus 0.03. Similarly, I press calc again, and now I can put in the value of A as 0.39 equals to the value of B is 0.45 equals to, then press equals to again. It gives me the error function as 0.03. And you can fill in the rest of the table as well. Okay. All right. The whole purpose of this exercise is to get familiar with the alpha function. Now the next table has a bit longer calculations. So this question or this table has been taken from a circuit from Agent 2023. Paper 5.1, I think. Yeah. So in that circuit, we have two capacitors that are connected in series. Now he wants us to calculate the value of capacitors at this point. Now, since the capacitors are in series, we know that the values of the total capacitance can only be calculated by using 1 over C plus 1 over C is equal to 1 over CT. So this is capacitor P, this is capacitor Q, P and Q. So we want to find the total capacitance. So if you look at this formula, you manipulate this correctly, so you'll end up with CT is equal to basically CP CQ divided by CP plus CQ. Or you can simply put in this the same expression in the calculator as 1 over CP plus 1 over CQ raised to power minus 1 to take the reciprocal at the end, so that you can finally land at CT, or the total capacitance. This is the mathematical manipulation that you get from taking the LCM, right? And you can do this by just putting in the whole answer or the whole equation in the calculator directly. We're going to do it both ways so that you can know how to make the function, okay? So in this system, I'm going to use, firstly, I'm going to use the product over sum function. If you notice, this has been picked up from the resistor combination functions, right? We know that for capacitors, they are opposite to each other. So I'm going to try this one. So fraction, I'll choose alpha, but this time I'm choosing new variables, alpha x and alpha y. I don't have to mention this is x and this is y. I don't have to add a multiplication sign between them. The calculator already understands what this is. And similarly, if I added brackets over there, the calculator understands what I mean by that, okay? So I'm going to leave this right now over here. And then we have the addition of both of them. So alpha x plus alpha y. Now I press the calc button. He asks me what is x, which is 2.2 for me, and 1.5 for the y. So 2.2, I press 2.2, press equals to, the value stored. Now he asks me about y. The value is 1.5. I press equals to and then equals to again. It gives me a calculated answer that is 0.89. So I write down 0.89. Right? Now I press calc again. I go to the next section, that is 2.2 and 3.3. So I don't disturb the value of 2.2. I'm going to put in 2.2 again. Then y is 3.3. I press equals to again. It gives me the whole answer in one step, 1.32. Then I press the calc button again. I realize the third value is still 2.2. I keep it 2.2. And I change the value of y as 5.6. This becomes 1.58. So 1.58, right? Similarly, if we go to the next stage, we have 3.3 and 1.5. I press calc again, so 3.5 and 1.5, press equals to again. So this is given to me as 1.05, right? Now, again, you can fill in the rest of the values as well. Now we understand how to make the function using a calculator, okay? Now, for the next time part, he again asks me about the average and to calculate the uncertainties. We know if the values are given to us directly, what we can do to calculate the actual value, that will be 12.9 plus 14.5, since we're taking the average. It is mentioned in the question, by the way. So 12.9 plus 14.5 is equal to, and then divide this by 2, gives us the answer of, so 12.9 plus 14.5 divided by 2 gives us the answer of 13.7. So the answer is 13.7 plus minus. We need to find the error. So the error is going to be exactly like maximum minus minimum divided by 2. So in this case, that is basically 14.5 minus 12.9 whole range divided by 2 to give us a plus minus of 0.8, right? So rest of the table can be filled again. And you can use the same function that we've done in the previous slide, how to make the function the calculator to fill in these values correctly, accurately, and straight away. Now let's try the capacitor's other function and see whether we get the same answers or not. So what we can do is we add brackets and then we add two fractions, right? So this is 1 over, let's keep this alpha b, and this is 1 over alpha a. Let's keep it x and y so that we don't have to edit them again in the table that we have just mentioned, that I just mentioned over here, that I'm keeping x and y same so that we don't have to talk about it. Okay, so, and now raise this power with -1. You can use the same technique for parallel resistors as well, where you have to use 1 over r plus 1 over r and so on. Now again, press calc button and see what values do we have. So the last values that we put in were 3.3 and 1.5. Okay, so 3.3 and 1.5. Okay, so I press this value and it gives me, sorry, let's do the previous one. I think I mistakenly put in 3.5 previously. Let's try 2.2 and 5.6. So 2.2 and then 5.6. Now you can see that we're getting the correct answer, that is 1.5. But even if for this one I put in 3.5, which I did by mistake, so 3.5 is equal to, and then 1.5 is equal to, I get 1.05, which I got right now with the wrong value. Of course, I should have put 0.3. Sorry, 3.3. Now let's try 3.3 and 2.2. So calc again. So 2.2 with 3.3, and you can see pressing the ST button gives me 1.32. So you could have used this product over sum function, which is generally written as product over sum, and this can be written down in the pure LCM function that the formula actually looks like to you. Why we add this -1? Because at the end of the day, you have to take the reciprocal to make this function actually mathematically accurate. Okay, so this is all for today. We learned how to make function on the calculator and how to save time by pressing this calc button and just getting by the whole table to save time.